So hello students, so welcome to other short video. So in this short video, my main focus is just on identification. I am not discussing any questions, anything. Whenever graph is asked to you, you have to just identify it and you have to just answer to the questions of some common phenomenon. This is the minimum thing which is expected. So that we will be discussing in this video. So first of all, so I will be starting with basic setup. So this was a lever, vertical lever, horizontal lever, and there is a after load screw. Now this is a recording assembly. Now this lever is attached to a muscle. So whenever this muscle is going to contract, this lever will go in upward direction. So whatever recording is there, if it is stationary drum, it will be recorded as a straight line. It will not be straight line, it will be a line like that of a arc of a circle. So stationary drum, straight line will not be there, little bit curved line will be demonstrated. And if you are taking the rotating drum, then you will be recording graph like this. So now we will be recording simple muscle twitch. So in simple muscle twitch, first you are taking a time tracing. So for time tracing, you are taking tuning fork and you are just attaching it. So that is a time tracing. So that is a baseline. Now see, point of stimulus I have shown. So after point of stimulus, after certain time that contraction will start. So this will be called as latent period. Then in the diagram it is very clear what is contraction period and relaxation period, and in the end it is physiological curve. Exam point of view, you should know the answer to all these phenomena. What is the cause of physiological curve, latent period, everything. So this was simple muscle twitch. Then we will come to next graph, that is effect of temperature. So again we will see the baseline. So effect of temperature, how many graphs you will see? You will be seeing three graphs. So first graph which we are seeing is a simple muscle twitch again, and this is at normal temperature. So this was a point of stimulus. Now next, see what is observed, increased height has observed, and there will be change in latent period as well as contraction period. So this is a warm temperature, or not warm temperature, we are using warm saline. So next we will be using cold. So cold, everything is getting delayed except height of contraction is decreasing. So cold is recorded as 16 degrees centigrade, normal is 26, and warm is at 38. So this is the effect of temperature. If you are seeing three graphs, it will be always effect of temperature. Now for effect of two successive stimuli. So in effect of two successive stimuli, initially I have told you in previous my video that there is a drum, kymograph, drum is there. At the base of drum, there are two strikers are there. Projecting strikers are there. So you can increase or decrease the distance between two. Thus, you can adjust the distance between two successive stimulus. So S1 and S2 are there and two stimuli are there. So we will see now. See again simple muscle twitch is there. So this is a S1. Now second stimulus can fall anywhere, where it may fall in latent period, contraction period, relaxation period, depending on the distance between two projecting strikers. Now here, see what is happening now. Baseline. Now this is again simple muscle twitch. Now I am going to give second stimulus. So second stimulus is falling where? It is falling around relaxation period. So if it is falling around relaxation period, what will happen? There will be increased height will be seen. So if you see net result will be like this. We will be getting a graph like this. So here distance was there, some distance was there. Now I will further decrease the distance. Now in this case, S2 is falling where? In contraction period. Now again see what has happened. Now height has increased. So if you see again net result, you will be getting a graph like this. So now again there are various options are there. So here what I can see here now, S2 is falling in second half of latent period. in this graph. So here S2 was falling in second half of latent period, and other graph downwards S2 is falling in first half of latent period. If you see carefully, when S2 is falling in first half of latent period, height is going to remain same. But if S2 is falling in second half of latent period, height was increasing. So all that reason, everything is important. That beneficial effect, all of you should know what is beneficial effect. So this was effect of successive stimulus. After this, now we will go to effect of increasing strength of stimulus. So in this graph, if you see in your books, what is given M and B terms are mentioned. So M is what make, B is what break. In previous video, I have told you what is the break and what is M. So induced current is always more in break. And 20 is what? This is a distance. This is not a current strength. This is a distance between primary coil and secondary coil. So as you go proceed, distance will go on increasing, distance will go on decreasing, and at certain point you will get a response at B but not at M. So this minimum you can call it as threshold stimulus. So you will further go on decreasing the distance. See, now distance is 12 only. Now you are even getting response in M also, and B distance response is more. Further I have decreased now. So here I am getting certain response. Then further I am decreasing the distance between primary coil and secondary coil, but now response will remain same. So this is a graph which you will get. So you should know what is subthreshold, threshold, maximal, supramaximal. These are the common questions which are asked. So my focus is just on mainly identification. So now genesis of fatigue. So fatigue is a reversible phenomenon. Again now simple muscle twitch, single point of stimulus. Now in this case you are giving repeated stimulus. I am repeating, you are giving repeated stimulus, one per rotation. So one per rotation means whatever point of stimulus is going to remain same, and now you are going to get many stimulus. So if I give say stimulus number 5, so what will happen? Initially I am getting an increase height. So initially I will get increase out. Now what I will do, now I am giving the say 50, means 50 times I have done. Now just see what has happened. So now slowly height of contraction has decreased. Now I am going to 100. So in 100 it has occurred to a such a extent that now this it is not touching to baseline at all, and this is phenomenon is known as contraction remainder. So this is the identification, that is genesis of fatigue. So after that, now we will go to genesis of tetanus. So here in genesis of tetanus, we are giving many stimulus per rotation. So there are many muscle contractions. So that is why we are recording at a slow speed. So whenever you are recording at a slow speed, simple muscle twitch will be recorded like this. So now depending on frequency, stimuli will fall in various periods. For example, in this case, now stimulus is falling just around the end of relaxation period. Why I am telling you that? Because see, complete relaxation is seen. So this is known as trepe or staircase phenomenon. Now you will further increase the frequency. So what will happen now? Relaxation period, it is falling in the relaxation period. Initially it was falling at the end of relaxation period. So here now see, incomplete relaxation is seen. So this is known as incomplonus, where incomplete relaxation is there. Now you will further go on increasing the frequency. Now frequency will increase to a such a extent that now stimulus are falling almost in contraction period, but some in between some relaxation may be seen, fluctuation in that line may be seen. So this is incomplete tetanus. Now my frequency is such that it is at high frequency. So in this case I will be seeing sustained contraction, which is called as tetanus. So this was about tetanus. Now freeload and afterload, all graphs are recorded in afterload position, but here in freeload, when you want to compare freeload with afterload, this screw has to be removed. So now what is happening? Every time I will increase the weight, see afterload screw is not there, so baseline will shift. See, I am increasing the weight, so baseline has shifted. So similarly, see what all things are occurring. Every time I will go on increasing the weight, see 10, 20, 30 gram, baseline is going to shift because after load screw is not there. So whenever we will see the change in the baseline, that graph will be after load. That graph will be free load. Now see, this previous graph was recorded on stationary drum. Now here, this is a moving drum. So this is what after load. Now I have removed the screw. Now just see what is happening now. So this was after load. See, height has increased. Now since I have removed the after load screw, baseline is coming below. So this is a free load. There you should know why free load, height of contraction is more, everything that you should know. So this was free load and after load. So no after load screw, so that graph is coming below baseline. Now we will come to last graph, that is calculation of conduction velocity. So here you are giving two stimulus, means two stimulus at two different time. But one time you are stimulating near the vertebra, other time you are stimulating near the muscle. So you are going to get two graphs. So whenever two graphs are there, most of the time M and V will be written there. So just see now, initially V. So in this case, I have given the stimulus at vertebral line. So as a result of that, I was getting graph like this. Now I have taken that stimulating electrode almost near the muscle. Now just see what I am getting. So I may get a graph like this. So if you see carefully, see V white, there is a latent period of V will be more because distance is more. But if you take latent period for M, I mean to say when you are stimulating near the M, then it is less. So that distance you are taking, distance you are taking between M and V and difference in the latent period will give you conduction velocity. So with this we will come to end. So here you should know which property of skeletal muscle can be explained from the given graph. So here mistakenly I have written cardiac muscle, but it is skeletal muscle graph. Then you should know what are the causes of various phenomena, and you should also know why cardiac muscle cannot